transgenic variability. Like for the LNC-RNA study,
Yeah.
even though there was N of 3 in each group, like melatonin have N of 3, Baker have N of 3, those each 3 groups, like each N equals to actually 2 amines, so that there is no like intra-variability
Yeah.
between the mice. So that's like I found out that's the new thing, because when this like when I am showing you NO3, it actually means
It's
NO6.
NO6.
Yeah.
But in the in sequential section, we do we merge, we collapse the lysates of OBMN of 3 mice together.
Oh, okay. So your
So
N,
if n that normally the data I showed was with n of 3
that's
was actually n
N
of
of
9.
9. Oh, that's wonderful. I wanted to like say this during my presentation, but that never came out. No one was pointing out that.
Yeah.
Oh God, Muslim, I forgot everything. And Rachel sent her cop to
Yeah.
go through. I was like, I don't know anything about confidence.
You just read it and give
No,
your
I will.
a bit.
It's
Not
good
that
for
much.
me.
If yeah,
It's good.
because we will have to cross that bridge when time comes. So that's not a bad idea.
No, that's not a bad idea. And I want to start early
That's,
because I heard.
you remember someone said that these ideas are contagious. Sorry.
No, but you should start early because if you are like, you should start early. I know one student who did not. There are many problems because committee members are not like very strict about the time going the complex and all that. They will
I
help
thought
you.
that after I will give my committee meeting second in May, and after that for 6 months I will do this norms and awareness. But now my man is asking me to move the committee meeting early. Do it in Feb.
That's too fast. But yeah, for you it should be fast. Is there any way you can stretch your 4 years to 5? That's too much work to do it 4 years.
But then I have to stay 5 years in my country now instead of 4. The cabbage was not here. Is she coming?
Vivek sent a message that she will be 15 minutes late.
Yeah.
How much late?
15 minutes late.
Who has presentation today? You have.
Me.
You know how.
God, last time. I should stop doing that. This habit is very bad. Once I do it at the last moment and still somehow manage to do it in the last moment, I will not do it earlier. I did this pass ride is bad for me. Like in my head I'll be in pass for 30 to 40 minutes. I'll read the paper there. This is so bad.
I'm used to it.
No, Muslim, this is a very bad habit.
I cannot be long. I cannot present in 15 minutes.
What?
I cannot present in 15 minutes.
I gave you the paper.
You have given me this long paper.
Yes.
This is a communication paper.
Yes. My pleasure.
This is good. Good job, yeah. Like when did you first open the paper?
Apsana, actually I gave him 2 more, right? 1 more or 2?
He gave me paper like maths, but
Oh,
I
okay.
didn't
I gave 1 more.
share it with all of you guys.
Everything.
And then the maths and it, so I cannot present next to the after that. So I was finding that and his text came up. And I asked him that I'm busy, don't disturb me, I'm finding the paper. The paper you have given me has been taken away. So then he sent me another paper in this nature communication paper. Monday night 8 o'clock, 8 p.m. And I just sent that paper to Dr. Kavanagh and
Oh, you
didn't see
did
the paper until next morning 5 o'clock.
What?
Nice. But you're lucky you didn't have to present.
So when I came in the class and the John's presentation was going till 9:50,
Oh, I was so
I
happy
stopped
about
it.
that.
I stopped preparing.
I was like,
Like, I
there
knew
is
that
no
my
way.
turn will not come.
There is no way.
I can feel you guys are asking a lot of questions to just fill the time.
You don't want. I
way,
don't-
way more
I didn't
than
want to present.
usual. Especially Muslim.
Muslim was so interested in your paper. Like, why?
He was, I kept watching him and he was not interested in the first, so he was keep like working on the presentation and then later on he started asking, he was
Till
happy.
that time, I was
Yeah,
sure
why
that I
did you
won't be
do
getting my
much
chance
about
today.
that? It's so much. I feel like, oh my god, Muslim, why do you care? Take
I
your
was
time.
really not interested in the paper, Like, I just wanted to not my turn to come at on Tuesday.
Oops.
I was hoping my turn won't come either. But then it did.
Yeah.
So much. It paper open.
How was your preparation? Good.
Thing is,
Presentation.
we are not able to finalize our third specific game.
Oh, that's fine. But
Mhm.
is your
Like-
presentation prepared?
Hmm?
Is your
The
presentation?
presentation is ready, somewhat, but
Kavanaugh's class.
no. He's asking about some other presentation. The falls are in.
Oh.
Monday.
Oh. I forgot.
Next morning, next morning.
I thought mine. I'm
So
so
the presentation is
involved.
ready. Just that I don't have my third specific game. I don't know like what to
It's okay.
do with my third specific
You
game.
can say standard instruction.
And
Or
like
you can say
60,
I
60 to, I would say 70% is like last year's stuff.
Mhm.
Oh, it's
Who
okay.
remembers?
That's
There's
totally
some
fine.
Optimization data.
That's good.
Added some optimization data. And then
Looks very scientific.
I-
Lots of
This
IO6,
is-
IO alpha.
the only data that I will have mine, I guess, the optimization data, and units it failed, so I could not even show any data.
For first year we can't show
Others, I
that.
guess,
Only
not.
that I showed was few Western blocks and that's it. All the rest was previous data. So it's fine, it's fine.
But then I'm proposing like new studies, so which is good. Few studies we don't have the capacity to do it in UK. Like you'll have to ask for some,
Mhm.
ask someone fit on CMU.
Mhm.
I don't know if they have it.
Just make a separate document file with all the questions you get or feedback you get for each seminar because those questions will come again and again.
But
Just make a file and just keep adding.
I'll tell you the only challenge is I'm going beyond 30 slides. So if I go beyond 30 slides, that means like I'm going to overshoot.
Wow, he's
that's the
so
only-
self-aware.
Yeah, I'm super aware about my. I should not overshoot time.
I had 39 slides. I finished in 32 minutes.
Huh.
Exactly, that's what I'm saying.
Like, how-
My ma'am
It's
told
not
me
the
next
case
time
with me.
I will give you 55 slides.
55
I
slides.
think you still finished it under 30 minutes.
30 minutes.
Yeah.
That was way faster.
So with
You were
Muslim
jumping, jumping slides. You were jumping like
So with Muslim
you
it
said
seems
two.
this number of slides does not matter.
That does not
He
matter.
thinks
He has his like a clock in his brain.
Mm.
Like
that
all the
maximum speed is 30
yeah.
minutes.
all the information will be there. What will you do during your final dissertation meeting, like when you were granted PhD?
30
You
minutes.
talk for 1.5 hours.
Oh.
I don't care.
So this will help you during your ORP definitely, but won't help you in your defense.
Uh,
ORP, yes, it will help you. because we just have 20 minutes. And if you shoot, like if you I did not
Hmm?
email this guy. Chetan is waiting on me.
Just stop messaging me. I am his lab member.
Oh yeah.
Betrayal.
Oh no, not the betrayal.
Same here.
So-
I'm so hard.
So there was this person in pharmacology. I don't remember his name. He is an MD now. So
MD.
MD like a doctor. Like he's
He's a doctor but
physician, yeah.
PhD.
Yeah, doctor plus. He did
Double doctor?
he did his PhD here and then went to
In the medical
to
university.
go
medical school.
like, yeah, went to
He's a
do
doctor,
medicine.
doctor.
He's a doctor plus doctor, right? So the
MD
person was over here, like in UK,
Mm.
and the person shot like just 1 minute beyond. He went 1 minute beyond 20 minutes in his
Mm.
ORP, and Dr. Witten was like, "What is this?"
Oh, God.
Because they're that serious in ORP.
Yeah, I
You should
know, I
not
know.
shoot.
I will finish
You should not shoot.
Okay.
20 minutes.
Even then, Dr. Whittier will ask, what is this? But it has to be like exactly 20 minutes.
20 minutes, yes, exact 20 minutes.
I-
Because
I-
I remember that person, everyone started making faces, like everyone started making faces. Moment he overshot like just 1 minute. He was
1
actually
minute?
finishing. He was on the conclusion slide.
1 minute
They
is.
did not stop. Like Dr. Whittle was like, we also have jobs.
Hmm.
It's like, oh my god, just 1 minute.
Mm.
And then the person comes out and then he spreads this thing to everyone. Prepare for 15 minutes. He'll be
The
talking to-
Muslim was born prepared.
I very
So Muslim, do you have this thing in your mind that if it is, say whatever be the time, you have to like
I can
subtract
speak
20%
more
of
than
the
35
time?
minutes, so that's the rule.
Is it because you used to take classes? That
No,
helped?
the problem was there as well. The problem was there as well.
Wrap
There
up
was 15
quickly.
minute lectures and I used to finish it in 35, 40 minutes.
And
Hmm.
what did you do?
Go away.
Wow,
Go play.
I would love to be on your class.
Students like that. Finishing 10
Yeah.
minutes earlier.
Hmm.
Every student.
Hmm.
I benefited from the questions last year. Like I knew Dr. Vicky will ask me about the male and female things. She's
Our lab will
really-
always ask you about. the
Your
female
lab
things.
also interested in male female thing,
Yeah.
right?
And for your
Right?
lab,
But I
Every
know
time.
this question will come
No,
up.
the thing is, if you have this advantage of showing a sex difference,
Uh-huh.
you get funded really very fast.
Oh.
NIH funds you really well. Like if you show some difference in females versus males, especially females, because their rate of their study entry, the clinical trial entry, is very low
Mm.
because of the problems beyond. So yeah, if you studying differences, it is funded very quickly.
Mm.
So I knew that this question will come up, so I was prepared for it. So when Dr. Vicky asked that question, I like the answer.
with each seminar, it gets a bit clearer, like which lab will ask which question. Because your
Yeah.
lab is all about figures and
Mm.
like figures.
Mm. Always
Any
figure.
kind of figures, you guys will go deep into that. You guys will count the data point and ask questions on that, or go to the Western blot, point to the pen, say this one is lighter than this one. It's good. It's good. But that's what.
Taking that seriously.
No, no. I'm just saying. Because I saw you doing that, Anuj, Christine, like
Anuj
they
Christine
all
used to
commented
kill
on
us, like they used
the
to-
figure. It's good. I'm not saying it's not good. And then your lab, Dr. O'Donnell, you'll go to the inflammatory pathways, cytokines. Like
Yeah,
if
it is
there is
more
any
immuno.
mention of cytokines.
So Dr. Lauren won't go. I especially go because I have that background.
Mhm.
Otherwise, Dr. Lauren won't go into
No, Dr. Lauren
inflammation. She
also
goes into
like
inflammation.
ask like why this pathway, how
Yeah,
you
what
this
Dr.
pathway.
Lauren I've seen is that she asks the alternative methodologies.
She,
If you are doing
exactly.
this, why can't you
Mhm.
do this? Or you this, you do this.
Mm.
I've faced these questions from her normally.
I'm facing that
Mm.
challenge in my
even in
presentation.
my committee
She
meeting
wants alternative.
when I was presenting the diabetic sequence like section. So she said that why are you doing that?
Mhm.
Mm.
Like why you have to do this process? Without this process this thing can be done. So
Mm.
she needs explanation for the processes, like
Mm.
methods. So we do know like she likes to ask that. That's what I'm.
She looks for more validation. Like she thinks
Mm.
you should not just prove it by one method. Like,
Yeah,
Mm.
dual
Take-
method
take
per
multiple
se.
methods,
Yeah.
yeah.
No, that's a good approach.
Mm.
With all the variables for one, yeah, it's a good approach. And then my professor would be all about male, female, and then
But then you're,
pharmacology.
but then Dr.
related stuff.
Vitandavi, if she's writing an ANIH grant, she should definitely put your data, like the 6 different studies. Like very robust. Like despite Krishna Wallace, we saw like our data is
The people.
falling in that ways.
So, are you talking about the stats in the class which we
Yeah.
with Dr. D? I was absent.
Mentally, right?
Yeah, I was just physically present.
Oh, you just finished your.
Just finished this
Oh my God!
presentation.
I am not taking into consideration of anyone else's presentation. So I mean, okay, yes, you guys just. I know, I
I
understand.
was just there sitting. I don't know what was
No,
going on.
it happened same for me the last time when she was describing the ORP, the comprehensive. She was showing, I think, Manisha's. Yeah,
Mm.
I was
Immediately
like,
after the
Hi, sorry. So, just to give you a heads up, I have my radiation started today. So it's at 7:40, my appointment at McGee. So this was the longest one, they said. So should be okay moving forward, but just in case I'm a few minutes late here or there, you know where I am. Okay, did anyone tell Chetan?
I
Okay, thank you. How's everyone doing? Good.
How was your visit? Man?
That's fine. I mean, you just lay there.
Yeah, are you
Very
feeling fine?
still. Yeah.
Are you feeling fine?
I feel fine. Yeah. She said, the first one, it's, it's after a few, it starts to get inflamed and you might get tired and it might irritate, the area a little bit more.
Mhm.
We'll see. But today I feel fine. It's just, I have to get up at 5:30 to make it there in time. I have long days now, but that's okay. It's alright. It's all good. Relatively, I'm very lucky. They caught it early. Don't need chemotherapy. So, relatively. Yeah, I had to put in some grades for your class. I mean, you're all doing fine. It's just, you're all doing fine. So it's just the grades for these two present, assignments. And I still haven't gotten a chance to connect with Dr. Johnson about if we want to give, I think in the syllabus it said 2 exams or 3
Three.
exams.
Three.
So it might
Yeah,
go down
three.
to 2 at this
Okay.
point. Just have some few more assignments or something.
Recording in progress.
He's projecting late.
Okay, well, hopefully he'll come in with us. Oh, there he is. Hi, Chetan. Alright, let's go to Dory, right? My email, I'm guessing your presentations are in there. Who do we have yet? Matt, Melanie, Vivek, and, okay, so 4. So hopefully we just get them them done today, even though I'm a little bit late. So 4, we have,
I'm just emailing you. I'm
okay, we have 40, an hour and 10 minutes. Divided by 4, 6, 7. Yeah, so like the 10, 15 minutes. I think that's what we've been doing. I'm looking for email. How are you today, Chetan?
I'm good, how are you?
Good. Thank you for your patience today. So I'll just start with Melanie since it's the first one I came to, if that's okay with you, Melanie?
Okay.
Good luck. Melanie. And you.
Okay, so good morning everyone. So we're not done with the date yet. So I'll be talking with the
right.
same about the same
Oh,
compound,
we have to
but-
share this, I'm sorry, I didn't do that
Right,
yet.
right.
Sorry. Yeah, Chetan, we're gonna share it in a minute, sorry, I forgot. Share screen. Down there it's green, yeah, that one. And then just click on, yeah, there you go. There. Okay, now can you see it, Chetan, and see us?
Yep.
Okay, good.
Okay. So the paper that I chose discusses how gallate affects the inflammation pathway through neutrophil activation. And basically it talks about the particular beta and gamma subtype T1 and gamma 2. So, and then they looked at this several processes. And then prior to that paper, they actually had a previous work wherein they tried to identify which is the binding site of gamma I, beta 1, and gamma 2, GI, beta 1, gamma 2 subunit. So they did peptide library screening where they were able to identify certain hotspots in the protein that is where certain peptides will bind to. So in particular, they got this short peptide SIGK, and then that's how they were able to screen out these small molecule inhibitors. So this is their positive control peptide compound M119, and then incidentally, this gallin compound is very similar to M119, except that it has the benzene ring here instead of the cyclohexane. And then these two at the bottom are the negative controls. So if you would notice, they just differ in the hydroxyl group. So it's very, I just found it interesting.
Yeah, it is interesting. So the
Yeah.
hydroxyl groups are very important,
Yeah.
obviously.
for this particular protein binding. And then also they use this for their experiments as the negative controls. Sorry. And then so they did the first what do you call it? A competition phage ELISA wherein they introduced this SIGK peptide, that short protein peptide, to investigate whether gallin affects the interaction of beta gamma with this short peptide. And then they noted that actually gallin did produce a decrease in peptide binding as the concentration of gallin was increased. So probably gallin itself will bind to the beta gamma protein itself, but they did not actually reveal which particular binding site in the beta gamma will these hotspots would be. So I tried to do some simulations. So
Oh,
just
wow.
out of curiosity,
That's
because
fun.
the beta subunit is available in Neutron, and then also the gamma subunit is available, and then so I know that the short sequence the SIGK. So probably um, it binds to the beta 1 subunit instead of the this is the gamma, this is gamma 2. So if you would look at the docking scores, the more negative the values are, it means that it's more likely to bind. So I was just curious.
No,
so I
that's
did this.
interesting. Yeah, I was going to ask you that actually. So I'm glad you did this. I was going to ask if they knew where it was binding on the.
Yeah. So they didn't show in the paper, but I just thought maybe I could do some.
Yeah, that's
calculations.
great.
So yeah, so it probably most probably binds to the.
So what's this?
Beta one?
Hep.
Oh yeah, so that
H-
is a free web server that you can use to bind proteins and peptides or proteins and proteins.
Oh really?
Yeah. So.
Could you send that to me so I can put it up
Sure.
on the class site if anyone's interested in checking it out?
Yeah.
Okay, thank
So
you.
this lab is, I think they are in China.
Oh, okay.
Lab, that you just have to upload your work and then it will run on their server.
Very nice.
Yeah. So it's free, so it's cool.
Yeah, it is cool.
And then after that, they actually did a direct binding assay. So they used surface plasma resonance experiments. So what it does is it gives you an indication if a particular substance binds to a protein according to the changes in the refractive index. So it does have a metal detector that reflects light, there's a prism, and then when binding happens, the refractive index changes. So that's how they detect. That's how they tell that binding actually happens. And also they observe dose-dependent changes in the response when gallane was introduced to the G beta gamma protein.
So is that? I mean, is anyone familiar with these assays? These are something
I actually have it.
Oh, good. Thanks. Yeah, let's see.
At the bottom of.
Okay, good. Yeah. Let's
I
see.
just wanted to show you how it.
Yeah, no, it's interesting because.
So yeah, this is how it looks.
Oh, okay.
So this is a metal sheet, and then they have a prism, and then they introduce light, and then analytes are passed through. So that's how the assay is done, and then consequently they would detect the changes in the refractive indices. So without the analytes, the prism would refract the light, but with the analytes and binding happening, it shifts the angle of the refractive index.
Okay, cool.
And then this is actually how they also experimentally determine the KD, dissociation constant. So apparently it has also some binding kinetics happening in there. So the rise in the curve tells you that the protein and the peptide or the compound are
Coming
binding.
to okay.
Association phase, and then it will reach some equilibrium, and then later on they will have to separate. So dissociation, and then the protein will be free, and then so that the other molecules or small molecule inhibitors could bind.
Yeah, that's really cool. Do we have the ability to do this here? Do we know downstairs somewhere?
I'm not sure.
Pharmaceutics or something? Yeah, I have no idea. Yeah, that's neat.
Yeah, so I also wanted to explore more about this because Dr. B would like to.
Oh, do something like this?
But I'm not sure if I think it's not here.
Here, probably at
probably
Pitt.
some. Yeah, probably.
Yeah.
So they were able to determine the key.
So did they isolate the beta gamma subunit? Is that what it was?
Yeah,
Isolated?
they
Okay.
did.
Nice.
Yeah. So that's peptide bond. Yeah. So and then what did they check next was the effect on PI3K gamma activation. So this is a newer study. They found that specific binding site of G beta gamma with the particular subunits of PI3K. So that is the P101 and P101, P110 gamma. So this is the regulatory subunit of PI3K, and this is the catalytic subunit. So G beta gamma actually binds to P101. And then what happens next? So this is here.
Yeah, these are nice diagrams. Are these
Okay.
in the paper or you found them?
I have to look for
Yeah,
other
they're nice.
papers.
Yeah, really
Yeah.
nice.
Yeah, and then so that's what happens. So beta gamma would dissociate upon receptor activation, and then um, interact with P101, which eventually will be activated to um, this bisphosphate groups in the cell membrane. It will phosphorylate it to PIP3.
Ah,
So
yes,
this is what
uh-huh.
happens. And then this is responsible for recruiting the effector proteins that. So in this paper, they looked at the pH domain containing proteins, so such as ATP.
Yeah.
So it will go.
Yes.
It will translocate through the membrane. So further for the experiments, they also later on induced neutrophils from HL60 cells by just incubating them with DMSO.
Wow.
And then and then so they would look at this particular pathway, PI3K gamma, PAP3, and then DTP. And then later on observe for ROS production and neutrophil migration. And then for they did next a Western blot to check if the ATP actually translocated to the cell membrane. So that was so that's the normal process. And then they checked if galley would affect that process. So FMLP is a bacterial peptide chemoattractant. That's what they use to activate the GI, the GPCR GI system. And then so in the presence of FMLP activation, so they observed ATP translocation, which was inhibited by M111, which is the positive control, and galley. And then they did next investigate RAC1 activation, which is another GTP. So they observed the same in that gallin and the positive control inhibited RAC1 activation. So they did that through RAC GTP assay. So there's a commercial kit for that. And then so why did they have to investigate RAC1? Because RAC1 is needed for NADPH activation. So you need to produce superoxide for neutrophils to be able to kill the bacteria. So that's an important process that they had to also investigate. So how gallin would affect this particular process. So RAC would be needed to. So this is the entire NADPH oxidase complex. So it apparently is needed for the enzyme to work. And then I looked for some connection on how they transition from ATP to RAC1 activation. So I couldn't find it exactly in the paper, but I found this review paper that there's actually a crosstalk between PI3K pathway and RAC. So probably that's how they were led to that next steps of the experiments. And then so they actually did superoxide formation assay. So that is through the nitrotetrazolium assays, NTP, something like that. So it is initially pale yellow in color, but in the presence of superoxide it turns blue. So it's more of a colorimetric determination. So what they did this time was they also incorporated fluorescein, which is the negative control, and workmannin, which is it is a known PA3K gamma inhibitor. So that's the positive control. So it also showed that gallin decreased superoxide formation. And then on this part of the figure, they just compared process that is independent from G beta gamma activation, that is through the 4-Bolmer state acetate. So it is also a compound that could produce superoxide, but using a different pathway. So I found it interesting that they were able to have this setup also to check if the process actually occurs through this beta gamma activation.
So did they treat with the FMLP in all cases?
Yeah,
Okay, and then
all
added the
cases, yeah.
okay, and then the
This
PMA.
PMA is
Yeah, yep, got it.
different
Yeah,
setup.
that's really.
Yeah.
This is a good paper. They've done a really good job
Yeah,
of.
I also
Yeah.
appreciated how they set it up. And then they also did next the chemotaxis assay. So chemotaxis would just mean like cell migrating. So this is important for inflammation, especially that neutrophils are the first responders. So they will need to check if the cells will actually move or how Gali will inhibit that. So this is just the setup that they used. It's called the Boyden chamber, where they place the test substances here. So that would be the Galin and then the other negative positive controls, and then the cells here which are at HL60, and then also they harvested primary human neutrophils. And then so as expected, so Galin.
We studied that chamber last
Last
year.
year.
Oh yes,
In
yeah,
methods
that's right.
one,
Yep.
In methods one.
Yes, I remember. Well, I mean, I knew that. I don't remember, but I knew. Yeah, we use Boyden chambers for migration with cancer
and,
cells as well.
Oh, okay.
Yeah. Mm-hmm.
So that's what they saw. So Gali expectedly decreased chemotaxis induced by FMLP. And then another substance that they use to check if it is independent or dependent of this pathway is the granulocyte macrophage colony-stimulating factor. So it also induces cell migration, but through a different pathway. So they showed that Galin do not act through
That
that
pattern.
pathway. And then this one is so additional stimulant. So chemo-attractant IL-8. So they observed similar responses, also decrease in chemotaxis. And then they also did concentration response curve for Galin. So this is in terms of chemotaxis. So increasing in concentration would decrease your chemotaxis. And then they moved next to checking the neutrophil recruitment and acute inflammation itself. So you would be probably familiar with the rat edema assay. So that's where they inject carrageenan to one of the paws, and then the other would be the test paw. So they did that and then investigated how would Galin affect the inflammation for that assay. So
they actually measure the paw thickness.
yeah, they did measure the change in thickness.
Wow.
So the comparison was with the other paw. So they measured it every 2 hours, and then so yeah, expectedly Galin also decreased the change in thickness. So and also here's another concentration curve, response curve. So
what does do you know what compound is there?
I was also curious about that. I was thinking it's just the saline.
Oh yeah,
solution,
like a negative control.
Negative
Yeah.
control. On the other form.
Yeah. Or the other paw, yeah.
Yeah, and then also they after the paw assay, they sacrificed the mice. They got the
Tissue, yeah.
tissue, and then they collected the exudates and then accounted for neutrophils, and then also Galin was found to decrease the neutrophil count. And then this one is a different positive control. This is indomethacin, which is a non-selective COX-1 inhibitor. So, yeah. And then the exudate would be just the volume of fluid that they gathered from the paw. and then they also, so that was direct injections to the paws. They also did oral administration of galley to the rats. So yeah, so they also observed similar trends in the results for galley, and oh, they have this positive and this negative for okay. And so to summarize, so the small molecules identified in this paper M1119 and shortened as galley bind directly to GI beta 1 gamma 2 subunits and inhibits these processes, basically gamma RAC1 activation, peroxide formation, and neutrophil migration.
Nice. That's a really nice job. That's a great paper.
Yeah.
Actually, if you want a model of a good paper, you could go and look at that paper when you're
Yeah.
writing your own, because
Yeah.
not only, I mean, they've done positive, negative
Mhm.
controls.
Yes.
They pretty much thought of everything that
Yeah.
you know you think of. Yeah, it's great. And what's the title of the paper again? I'm sorry, I just.
It's a rather older paper,
Yeah.
2008, but
No,
it's good.
that's young to
Yeah.
me. Okay. Right. So
Watch.
I guess if I'm putting myself into Dr. Leek's shoes right now, she would say, well, you know, some inflammation is good, right? Like a little bit of inflammation is good, right? So I'm wondering what is the clinical application for this then? What were they?
Yeah, I was thinking of that. But
Yeah, I mean, I don't know. Does anyone have any thoughts on that? Yeah.
In any condition where you have like inflammatory dysregulation, which leads to more inflammation, cytokines release,
Mhm.
then you can stop chemotaxis.
Mhm.
And then, like for example, we have seen in the viral infections that there is increased surge of a surge of chemokines and
Okay.
inflammatory processes where you can use these and stop inflammation at a point that it cannot hurt the body.
So allow it for a little while to help clear whatever insult is there,
Yeah, maybe.
and then maybe stop it after a point if it goes into chronic. Maybe I don't know.
Or maybe you know that at this time point the inflammation is not good for the
Beneficial anymore. Yeah,
beneficial for
right,
the, you
right.
can just give that and stop
Right.
it.
Yeah, that's great. Yeah.
I was also thinking that you know that we need inflammation. Like it's a normal, it's a needed process, but
Yes.
it becomes problematic with chronic inflammation. So
Yes,
probably
right, yeah.
there's a needed clinical use of galley.
Mhm. Yeah. Very nice. Yeah. Good. Thank you, Melanie. Very good. That's a really good paper. A good one for you to keep in your files, just to see, you know, all the controls they did. Even if you're not doing the exact experiments, it shows you how they thought about them in different ways.
Mhm.
Very good. Okay, let's see who's next. I'm just gonna go down my email, whoever's there next. Musa,
I just
are you still seeing our screen now? No, probably not. Hold on. Hold on, Chetan, we'll make a new screen share here for you in a minute. There we go. Now you can see it, right, Chetan?
Yes, I can.
Okay, good. Alright.
Okay, welcome everyone. The article which I'm presenting today is targeting G protein coupled receptor signaling at the G protein level with a selective nanobody inhibitor. This paper is related to llama-derived nanobodies, which basically have been shown to inhibit G beta 1 gamma 1, and these are newer molecules like Galine M119. They were discovered earlier and they have been tested more. So you can see the like Galine M119. You will see there are more applications. People have used and tested them in different experiments. But this nanobody inhibitors like NB5 llama-derived nanobody inhibitors, they are not being tested as that much. So this article was more related to its binding capacity and finding out its mechanism, how it's working, and what potential application it can be fit into. So that's what this article was showing up. And this article also gave many details regarding the medicinal chemistry. And then in the end, they also gave applications like how it will affect the disease, or it has the potential to treat the disease. So I've not taken the medicinal chemistry part because it's not our domain.
Right,
So
sure.
I've just taken a chunk of this article to consider. So let's see what's there in. So before going into the article, I would like to share this mechanism of G protein coupled receptor, in which ligands bind to the G protein coupled receptor, which leads to dissociation of alpha, beta, and gamma. Alpha is separated out from gamma and beta, and both them have own their own cellular pathways. What has been shown is that this regulation of the beta gamma signaling can also cause neurological diseases and cancer related anomalies. So inhibiting that beta gamma can be a potential target, or a potential way to treat those neurological disorders or cancer related anomalies which are caused by maybe binding of the ion channels, like opening or closing of the ion channels, which causes dysregulation of these pathways. So inhibition of beta and gamma is more important in those, and we have to be very careful that when we inhibit this beta and gamma, we should not be inhibiting the alpha, because we need the alpha effects and we don't need the beta gamma effects in these conditions. So selectivity is also important. At the same time, we have to treat the dysregulation as well. So in this article, what they did was they took 17 llama-derived nanobodies. NB5 was the main one which they characterized further, but they took 17. What they found was that one of them, that is NB5, it tightly binds to beta gamma subunit, and it also competes for common binding site with beta gamma with other G regulatory proteins. They inhibit G beta gamma subunit, and there is no effect on GS and GQ.
So, what about GI or?
The main effect is on GI and GO.
Oh, okay.
Not GS and GQ.
Okay.
So what are this advantage of the nanobodies? Why they are using it? They are favorable because of their size, extremely small size, and their solubility, their affinity with beta gamma, and their ease of production. They can produce in a large number, and the most important thing is because of the size, affinity, they can penetrate into the hidden parts or hidden cavities of the target antigen. So they can give you a better binding in comparison to big molecules which cannot go inside, which cannot go in the folds and curves. So that's the advantage of the nanobodies. So they took 17 nanobody clones and did ELISA to check the binding, and the binding showed that out of 17, 3 were those which were binding tightly with G beta 1 gamma 1 subunit, and out of those 3, NB5 was the one which was binding tightly and was showing high expression levels, and then NB5 was chosen for characterizations. Another nanobody which was NB17 was showing no relevant binding, so it was taken as a control. So the method used for this purpose for characterization and for high expression levels and binding was that immobilized Ni2 affinity chromatography pull down assay. I exactly don't know what that process is, but we have discussed once the pull down assay. You remember that in the methods class, and maybe this is selectively separating out those molecules which are not binding, basically.
Right, yeah.
This is that type of assay.
Anything that binds will stick to the column, and then anything that doesn't will wash through.
Yeah. That's I think that this is
I think
the
so. I think that's what
we have
it is.
discussed pull down async methods class, and this was the main logic behind the using of
Right.
this
So this is kind of like an antibody, right? This nanobody, is it like an antibody?
Yeah, nanobody this type of an antibody.
Right.
It's llama, right? Llama is basically an animal. It's more like if you have heard about llama.
Oh, llamas. Yeah.
It's bigger than the goat
Yeah. Okay.
and smaller than
It's like a hybrid.
camel's too big
Too
to be
big.
compared with, but the shape is quite similar to camel.
Yeah.
Yeah.
Llamas
Larger
are a
than
little
goat.
bit bigger than goats, I think.
Larger than a goat, similar to camels.
Yeah. They
That's
they
it.
spit at you and stuff. Oh yeah.
Yeah.
So I guess on the column they have is that nickel? Ni2?
So when I saw their method, they kind of like overexpress the protein, then do the
I will
purification.
come to that,
So
yeah.
they use the nickel column to
Nickel column.
bind the whatever the tag. After they induce the IP with the IPTG, then the bacteria
Nano-
overexpress the protein. Then I think they just use affinity chromatography to just purify.
To get what's binding to them,
Yes.
their protein of interest, right? Yeah, okay. Do you understand, Matt?
So what they proposed was that this is the GPCR receptor, and whenever there's the binding of the ligand to that receptor, it causes the separation of the alpha and beta gamma. And here you can see that with the separation of the beta gamma basically starts activating GIRK channels, which leads to release of which basically causes the release of potassium ions outflow.
Right.
Causes the outflow of the potassium ions, which leads to release of acetylcholine and dopamine directly or indirectly. So this basically model is basically taking like these are minute spiny neurons of mouse striatum, in which they have overexpressed GIRK.
Right.
Because you know that the beta gamma activates GIRK, so they have to show that the GIRK is basically inhibited in minute spiny neurons of the mouse striatum. So they have virally overexpressed GIRK channels and then expression, and then they have given NB5, NB17 to look at the effect of NB5 and NB17. What they found was that NB was binding to beta gamma and inhibiting the effect of GIRK. Now this GIRK basically causes like dysregulation of the ion channels. Like when potassium go out, there is more release of what we call electrical transmission.
Mm-hmm.
So that stops when you give NB5, and that's not stop when you give NB17.
Right.
So more.
So those channels, they're kind of off. They're not channels we talk about a lot, but they are. They're called inward rectifying channels, but really the potassium's going out.
Yeah.
So when you block them, the potassium stays inside
Yes.
the cell and changes the excitability of the cell. Right.
Yeah, that's that.
Mm-hmm.
This is the result. If you can see that the NB5 showing in the first column, if the NB5 given and D2R shows the dopamine receptors basically, and activation of the dopamine. With NB5, this release has been decreased.
Mm-hmm.
And if you compare with the NB17, this release was similar. Like there's a significant difference between this one, NB17, and because NB17 is the control.
Right.
I told you that NB17 was not showing any relevant binding. So with comparison to the NB17, this release was decreased of the dopamine, and M4R is the release of the acetylcholine through muscarinic receptors. So this has been also decreased with the binding of NB5, but not with the binding of NB17, which shows that NB5 is binding to GIRK and inhibiting the outflow of the potassium, which leads to inhibition of the dopamine and acetylcholine. But with NB17, that was not seen, and with the control and NB17 was showing the same result, which was because they were not affecting beta gamma pathway.
So these are striatal neurons. They
Yeah.
already express dopamine receptors,
Mm-hmm.
right? And then they overexpress the GIRK, the potassium channel,
Yeah.
right? And then they treat it with dopamine,
They treat it with NB5 nanomolars,
NB
nanobody.
and the nanobody.
Yeah.
So this is just like basal activity of these, or like how are they inducing the activation of the receptor?
Yeah, basically what they are doing is NB5 is inhibiting the GIRK. Directly and indirectly both. You can see over here. Oh, sorry. Directly and indirectly both.
Right, but after stimulation of the receptor, correct?
After stimulation of the receptor, yeah.
So did they use dopamine to stimulate the receptors? Or how did they stimulate the receptors? Or is there just basal activity of this?
Yeah, that's the only the basal activity. They have
Okay.
not stimulated the receptor over here.
Okay.
They're saying that binding of the agonist will cause, but they have not stimulated it with this. They have only overexpressed GIRK.
Okay, alright. So this is some kind of basal activity.
Basal activity, yeah,
Okay.
yeah, sure. And you can see the amplitude percentage of with the dopamine receptor, it's going down, and with the muscarinic receptor with NB5, you can see that it's going down, but with NB17, it stays the same. So it's NB17 and the control have no effect on the dopamine and the muscarinic receptors.
So these neurons also express muscarinic receptors?
Yeah.
Okay.
And if you can see
Right, they're
time
just
different
straight
time
lines,
points,
yeah. Uh-huh.
at 5 minutes interval and 15 minutes interval, it has decreased considerably in both, like in muscarinic release of the acetylcholine and the dopamine.
Right.
But if you see the NB17 in the dopamine and controlling the dopamine, there is no difference in 5 minutes and 15 minutes because it was not actually binding to the beta gamma segment.
I'm going to call out Matt here for a minute. Do you remember the striatal neurons? What they're important for? What pathway we're talking about with dopamine?
I should know.
That's all right. I'm calling him out. I'm putting him on the spot. You can.
I can imagine they
You
studied
can
too
help
much.
him. Phone a friend.
Please.
No.
What's the pathway?
Nice.
So for where the dopamine neurons originate. Come on, Muslim. You're in Leak Lab, right?
Yeah.
Ah.
And
Niagara. Yeah, substantia nigra, right?
Substantia nigra.
And they project to the striatum, right? And that's the nigrostriatal pathway. Really important for what?
For
Well, Parkinson's disease, but like in all of us, hopefully without Parkinson's disease.
for movement.
Right, movement,
Yes.
right? Our intentional movement.
Right.
And remember, it's the balance of dopamine and acetylcholine.
Mm-hmm.
So it makes sense that these neurons have those receptors.
Right.
So I was just putting in a little bit of physiology
Right.
there for you.
I've stuck to beta gamma.
Yeah, I know. Yeah.
Okay, moving forward. So one is this was basically related to the neurological disorder. As I told you that dysregulation of beta gamma leads to neurological disorder, and it can also lead to cancer disorder as well. So one model they have shown with the neurological one, they have taken minute spiny neurons. The other model they took was like Chinese hamster ovary cell lines, and they were looking over here with the P13K protein kinase B AKT pathway, and then MAPK and pathway.
Always, everywhere.
Everywhere. When we talk about cancer, it
Yes.
comes
Yes, it
Yes,
comes up.
immediately.
Yes.
Yeah. So they have taken Chinese hamster ovary cell line, and then they have basically they were expressing human apelin receptors, and then they transfected it with NB5.
I've never heard of apelin receptors. Did you happen to look up what that is or anything?
No, I was
Yeah,
saying
okay,
I was
yeah,
more involved in
Yeah,
this.
I get you.
I just know that it's an agonist
Okay.
Yeah,
for
seems
binding
to
to
be.
this GPRC.
Okay. All right, that's fine.
And they were looking with the binding of the last time it was only basal activity in the neurons, and this time they are working with the agonist apelin.
Mm-hmm.
And what they have shown is that they are transfected apelin with the NB5,
Mm-hmm.
and they have seen that with binding of apelin, like normally what happens, activation of these both two pathways over here, and these pathways are related to like proliferation and survival of the cells, growth, proliferation, and survival of the cells. But normally this happens when only apelin binds.
Right.
But with
Okay.
NB5,
Right.
there will be inhibition of beta gamma,
Uh-huh.
as we have also seen in the last mod.
Right.
And if you can see over here the Western blots, that without apelin there was no effect, because now this binding of apelin was necessary.
It's
You need an
required.
agonist.
Yeah, okay.
So there was no effect in the phosphorylated ERK1/2 and PS473 AKT. So AKT pathway and ERK pathway both were not activated without binding of the apelin. But once this apelin bind, you can see that there was a difference in the band size, like with NB5 and with like NB17 and NB5 were showing different sizes of the band. You can see that over here the phosphorylated ERK1/2 have shown decreased small band of the phosphorylated ERK1 and 2 and a larger band with NB17, which shows that ERK1/2 phosphorylation of the ERK1/2 was more when NB17 was there and less with NB5, which shows that NB5 was blocking the phosphorylation of ERK1 and 2, so the pathway was not activated. Similarly, the AKT pathway was also not activated when NB5 was binding, but it was completely activated when NB17 was binding. That's the difference between the quantification of the phosphorylated AKT and ERK1/2, and you can see there is a significant difference between when NB5 binds and when NB17 binds.
Right. 2 comments. Those westerns are beautiful. I don't know how they get such nice westerns. A. B. Did they say how they quantified that in the last graph? Did they take phosphorylated over total, phosphorylated over tubulin?
Ma'am, I have not seen that.
Okay.
But normally
I just wondered
they would have done alpha tubulin, like.
So what do you think? How would you do it?
We normally do with total protein.
So
To total protein,
Yeah,
right?
but they have done with alpha tubulin. Because
So
they
they've
will
done
be-
alpha tubulin.
With AKT, they have taken with total AKT and alpha tubulin, but for phospho ERK1/2 similarly they have taken total ERK, and
Yes,
then they
yes.
have also taken alpha tubulin.
Okay. What, were you gonna say something?
yeah.
So go ahead. I'm sorry.
So I was wondering, like, when they do, like, sometimes they say like a pen or like a total, so they so the denominator would be like phospho plus the lower band, could be like that.
I think it's between the total and this one, phosphorylated one.
Mm.
That's why they're saying phosphorylation. They are not saying out of total.
Right.
So,
So-
out of like the total
But-
protein or
but if
alpha
you
tubulin.
But if you see what they are saying, P arc
Over
over
ERK. Oh,
T
yeah.
T arc,
Yes,
so
you're right.
What-
They are taking it. Oh, they do show in the graph. I just noticed
Ah,
that.
yeah.
Yeah, so they are
It's
taking
total.
it over
That's
total
what I'm
protein.
saying. They are
Yeah,
taking
yeah.
total, not the tubulin. They
Right,
have shown the tubulin.
right.
They have shown.
I think
alpha
that's just
tubulin.
to show equal protein load.
Yeah.
So I will let you know that I don't think it's wrong either way, but I know that faculty in pharmacology want to see both. I'll tell you that right now. It comes up all the time. We want to see phospho over the total protein and phospho over the tubulin.
But that's,
And total protein over tubulin, because that'll tell you if the expression is changing too.
Right.
but that's also making very sense. Like it's logical, because if you are taking like the phosphorylation level should be taking the total ERK,
Right.
how much it's phosphorylated.
Right.
But you also need to have seen that the cells were like
Yes.
like alive, or like they were they were not denatured or anything. So you should also know the alpha tubulin completely.
Right. Well, also you should know the total levels. I mean, here
Yeah.
this is a really nice blot, and they don't always look this nice, as we know. But you can see that the total's pretty stable, like it's not changing very much, and the alpha tubulin's very nice. It's a really well. It's probably hopefully it's their best blot, and hopefully they have some crappy blots too.
Yeah.
But anyway, yeah, no. So yeah. So to see if the total protein is changing, you would take the total over the alpha tubulin, and that's also important because expression could change as well as phosphorylation. So we like to see it all. We want to see all those ratios.
Yeah, you will do 5-10 times and then you can
Yes,
Yeah,
yes.
yeah, exactly. Right.
So next
Are you
time-
following along? Take time what we're talking about.
Yes, I can understand.
Okay, good.
Thank
Because when you get here and you start doing your presentations, this will come up over and over again if you're looking at any kind of kinase activity or any kind of westerns. We like to see a lot of different ways of analyzing those westerns. So.
Then I would also like to show that NB5 is acting as a control switch for GPCR mediated G beta gamma signaling. Like when you have to stop it, you can stop it through NB5. Like if you can see over here that beta gamma and alpha both basically inhibits ATP conversion of CMP over here, and then this NB5 inhibits only beta gamma, not the alpha one. And you can see over here with the drug response curve, and when it's given with CHO APJ is with apelin plus in the Chinese hamster OV cells. So CHO is that and APJ is apelin basically. So they are given together with either NB17 with NB5, and there is a drug response curve, and you can see that the CAMP accumulation was completely seen with NB17 because NB17 was not having any effect on the beta gamma, but NB5 was having a lot of effect on the beta gamma, not alpha. That's why you can see that there is 42% of the accumulation, not 100%. Like not 100%. It has been decreased half.
So you're decreasing the efficacy
Yeah.
of the beta gamma subunit, sort of.
Yeah, I would say
How would you
decreasing
say
the
that?
efficacy of overall activities of GPCR.
Okay, yeah, okay.
Not
That's really nice actually, because maybe you don't need a full-on block of the response. You just need a little bit of a change. That's cool. And then what's F showing there?
F is showing basically binding of the agonist, and without blocking, what happens is GS and GQ both are activated, causing ATP to convert to CMP, and which causes release of the calcium to phosphorus.
So GS and GI, beta gamma is not affected by this at all.
Yep.
Okay. Got it.
So what I've saw like this is the new basically nano body. So I was looking at what applications it has. So I found that modulation of mouse rod signaling by gamma drive transduction. So we are now looking like these are coming out applications. How these are used. They're using the eye mouse rod these rods and cones of the eye. So they have treated over there. And then gamma drive signal variable domains directed against chemokine receptor reduce head and neck cancer cell growth in vivo. It's an old article, but this one is coming up. There's one or two more which I didn't show up, but now the applications of NB5 are showing up more.
Nanobody. So can you just one more time? What a nanobody is a fragment of an antibody?
I didn't read that much,
Okay,
but they are taken from llamas. They have also been taken from camelins, and these are very smaller than the antibodies.
Than mouse or rat.
Yeah, and their size and affinity towards receptor is a great advantage with respect to with comparison to the other small molecules.
So do llamas just make smaller antibodies? Is that the deal? I don't understand. I mean, I just, that's interesting. No, these are cool. I never even heard of them before. So something to look for, Could have applications.
It seems a very reliable thing.
Yeah.
Because it's published in Nature.
Yeah, Nature, yeah. Well, anytime something new like this, that's cool. All right, thank you. Who is left? Matt and Vivek, right? Hopefully we can get through them all here. Coming. Oh, wait, Matthew's next, sorry. He's next on my list. I'm just going down the list. Sorry. Okay. I got Vivek all ready to go. Okay. So Matt's up.
So the paper I looked at was looking at G beta gamma inhibition in treatment of heart failure. So I'm just going to first just quickly go over why we're looking at G beta gamma in heart failure. That is because the beta adrenergic receptor plays a big role in heart failure. So one of the characteristics in heart failure patients is overexpression of catecholamines. And because of that overexpression, they bind to the beta-adrenergic receptors and kind of cause all sorts of problems. And I'll be honest, when looking more into the beta receptors in heart failure, it kind of got more confusing for me rather than less.
Did you start taking deep dives into these things?
Because then you have like downregulation of beta 1, and then that increases the proportion of beta 2 receptor, and it just kind of got all over the place. But this paper was specifically looking at M119, which inhibits right at the beta gamma GRK2 in the pathway. So the first thing that the authors looked at, they just wanted to get, just wanted to see the effects that M119 had on cardiomyocytes outside of the mice. Sorry. And so they looked at to see if they would have increased cyclic AMP when given M119. So the way that they did this was they actually also gave the mice, the cells, isoproterenol, which is an agonist of the beta receptor. And what they actually found was whenever you give isoproterenol and M119 together, you have increased cyclic AMP production compared to just isoproterenol alone. And then on top of that, they also looked at to see if M119 would affect the expression of GRK2. And so what they found was when given isoproterenol alone, it increased the amount of GRK2 inside the cell. But whenever given M119 plus isoproterenol, it increased compared to doing nothing alone, but not at the same level. So it was just a reduced amount of increase in GRK2. And so
I guess this kind of suggests that the alpha subunit's kind of left alone.
Yes.
Right, okay.
And so they wanted to then look at to see how that would affect the contractility of the cardiomyocyte. And so when looking at it, they did this in two ways. They just looked at the percent of contractility and the sarcomere length. When given these substances, so when given isoproterenol, contractility increased. Just because the beta receptors, when activated, they increase heart rate and contractility. But given isoproterenol and M119, it increased contractility even more. And so it also decreased the sarcomere length during contraction more, therefore more contractility. And they also, in this part of the experiment, they also gave propranolol, a beta blocker. And whenever they did, in conjunction with isoproterenol and M119, it actually just stopped all, it inhibited everything. So they said that this showed that there was actually selectivity for the beta gamma subunit. So the next step in this paper was to actually go in vivo, and they gave M119 to mice with acute pharmacological model of heart failure. So they injected isoproterenol over the course of 7 days to mice, and then they treated those mice 7 days with M119 isoproterenol. What they found was kind of interesting, kind of my experience with like treatment of heart failure. And so they looked at a couple of different things here. One of which was just like an echocardiogram of the left ventricle of the heart. And as you can see here, just given the isoproterenol and the vehicle, it kind of like, not really like an echocardiogram kind of reader, but you can kind of see the differences of just like the normal healthy heart, and then the heart with the M119 plus isoproterenol and how different just giving isoproterenol is. They also looked at fractional shorting, which is basically like the size of the heart, left ventricle whenever it's contracted and like in systole or diastole. And you can see the percent fractional shorting in the isoproterenol group is significantly lower than when given M119 as well. And then they also looked at what effect that this would have on the hypertrophy of the heart. And so they took, the way they measured that was they took the weight of the heart and compared it to the body weight of the mouse overall. And you can see in the isoproterenol group that there was a significant hypertrophy of the heart because the ratio was much higher than the other ones. And then lastly, this last figure in figure D, they showed that, I'm trying to actually remember now which one. I think, if I'm remembering correctly, the group, treatment group given with M119 had less interstitial fibrosis of the heart. I think that's it. I'm not a histologist either, so I can't really see.
I'm not good at reading those, but yeah, okay.
And then one could leave this as a little bit surprised, but whenever the next step was to look at it in a model of a mouse that already has heart failure, but they didn't use M119 whenever they decided to use gallium for some reason.
Well, let's guess the reason.
Yeah.
They probably didn't get good results with that.
Probably. So they actually, in this part of the paper, they looked at mice. The mouse models they use had overexpression of calciquestrin, which kind of leads the mice that have heart failure. And so at this point, they had either group treated with vehicle or treated with gallium for, they treated them for 1 month. And then they looked at the kind of the similar things here, fractional shorting, the heart weight, and I'm actually trying to remember what this last one.
Atrial natriuretic factor, which I guess is increased with heart failure.
Beta-myosin heavy chain.
And beta-myosin heavy chain. Yeah.
Yeah, I'm trying to remember exactly why.
Well, it looks like. Well, I think those are measures of. I think the beta-myosin heavy chain is a measure of contractility. Right.
That makes sense.
I don't know about the atrial natriuretic factor and ANF, but it looks like with the vehicle those are higher. So meaning that's an indication of heart failure if you have high levels of those proteins, and then the gallium decreases it. That's what it looks like to me. Yeah.
But basically, these results just kind of reflected the results of the pharmacological model as well. And then the last thing that they wanted to do was look at the GRK2 expression inside the mice rather than in vitro. And so whenever they did the analysis, they did both for M119 and gallium.
So I bet in that previous experience M119 didn't do it, for whatever reason.
And then the results kind of mimicked what was done before, where when given just the vehicle, there was increased GRK2 expression. Actually, I don't know why they did just the vehicle and gallium alone, and that one they also did isoproterenol in this one.
Yeah, I mean, sometimes, I don't know. I mean, it's always good to at least do the vehicle control with the drug at least a few times, but maybe they did it and realized that the vehicle didn't have any. Right.
But again, the results kind of mimic as it before. So that was basically everything that they went through with the paper. Overall, when thinking about this and what I know for like the treatment of heart failure and what we know, it was kind of weird seeing kind of like it kind of contradicts what I originally thought of, because in treatment of heart failure, and especially whenever we have reduced ejection fraction, one of the main drugs we give is beta blockers, and that's to decrease the heart rate. And that has been there's been many clinical trials showing that has rates effect and decreases mortality in heart failure patients. But at the same time, I think one of the issues is that whenever you have the beta receptors be flooded with catecholamines, increases heart rate and contractility, but only to a point. And so
Okay.
at some point you get increased heart rate without increased contractility.
Oh,
So
interesting.
my guess is that molecules like M119 and gallium then would increase contractility along with the heart rate.
In order-
Because whenever you have, if you want increased contractility whenever you have reduced ejection fraction.
Right.
And
Yeah.
I would like to add it over here that whenever there is a heart failure,
Mm.
heart failure is a gradual and chronic thing.
Right.
So what happens is when heart is failing down, it's not contracting that much.
Right.
The
Okay.
body
so
shows a
eventually-
feedback mechanism,
Yeah.
and it releases a lot of catecholamines.
Yeah.
And this is basically compensation for the heart failure.
Right.
Initially, this compensation is very good for like few days.
Right,
Like,
yeah.
But afterwards, what happens is this compensation becomes burden for the body.
Ah.
There is a lot of catecholamines over there,
Mhm.
but it's not increasing the heart rate as much as you like
Ah.
to, and it's not giving a positive effect.
Mm.
So what they have seen in heart failure, heart failure is very unique thing.
Mm.
The treatment, if you see the treatment of heart failure, there will be beta agonist and beta antagonist also.
Yeah. Right.
At the
Right.
same time, like if you
So to
see
make
the,
a balance.
you see the treatment of beta agonist, beta
Homeostasis.
antagonist.
Mm.
You can treat heart failure with beta agonists to increase the cardiac heart rate,
Mhm.
and you can also give beta antagonists
Blockers.
to
Right.
decrease the compensation.
Right.
It's seen that if you decrease the compensation,
Uh
the heart failure improves.
huh. Ah.
Even because if you continuously are releasing the catecholamines and causing heart to contract,
Yeah.
it doesn't do that. It only creates problems. It
Right,
only creates
right.
negative effects of those catecholamines.
Yeah.
When those negative effects of the catecholamines are eliminated, the heart improves itself. So
Sure,
the
yeah.
treatment of beta agonist and beta antagonist with heart failure has been shown effective
Right.
both ways. Both
Yeah.
ways, like
Right. I mean that makes sense. But in practice, I don't really see beta agonists used. Like, when
yeah.
focused. So
That's why-
like
because beta
because
antagonists show better effect than the beta agonists.
Yeah.
Yeah.
Right.
Logically, it's very difficult to
Yeah.
understand why beta agonist is not giving a good effect when you see that beta antagonists show better effect, because compensation effect is hurting the heart failure more rather than the contractility.
Ah.
right.
So
So,
what-
I'm struggling to find a place in therapy for this.
Yeah.
For the
Because of
compensation,
that.
for the compensation. This
Right.
paper is related to compensation, how to stop that compensation,
Right.
not increasing the contractility.
Right.
So with Galen, you decreasing the compensation basically, and at the same point you are also giving the heart for a bit of the contractility as well.
Right.
Right.
In both ways.
And it makes more sense, right? Because giving agonist and antagonist can be a tricky thing, right?
Right.
Yeah.
Yeah.
Yeah, no, I think you were on the right track there. I think that's what you kind of you're agreeing.
Yeah,
It's
yeah,
almost
yeah,
like-
right,
Yeah.
Right, because it's kind of like it doesn't make sense.
Right.
It's decreasing the compensation over here.
Yeah.
Basically.
Right. Yeah. Great. Awesome. So I wonder if you'll see this used in therapy at any point.
I'll know. Who knows?
Yeah. All right.
The thing with the heart failure too is that it's so much more than just a beta receptor stimulus. There's like
Sure.
fluid overload. And
Oh,
like
right.
the vascular muscle.
Yeah, I know. Like I tell you in HPP, when we learn neuro, this is just the
Yeah.
the icing. If you start to really think about it, it's
Yep.
like forget about it. Okay, good. One more. Oh, good job, Matt. Okay, one more. Chetan, you hanging in there?
Yes.
Okay, good. All right, let's find you. There you go. Oh, that's me late for class. I'll just search this. There it is. This one? This one? This one's? Yep. And let me just share this with Chetan here. Here, right? Oops. Okay. There we go. So like, okay, cool.
Right. Good morning, everyone.
Oh.
When I was looking up for papers that appreciate the role of beta gamma subunits what I realized, these subunits are basically more regulatory than having a direct effect of their own.
Nah.
And I'm glad that across the presentations that we
Yeah, no,
saw,
this is.
they're all showing like they agree to this, I guess.
Yeah.
So
'Cause
and
when-
that is
When we teach GPCRs, we focus mainly on the alpha, right? Going to the.
Mm.
So I like this twist on it, like understanding that the beta gamma, we just say, oh, that does things. Beta gamma does things, right? But this way we get a better appreciation of what it actually can do. Yeah.
right. And that is why the other day I asked this question to, I guess, Melanie, Sana, that
Someone.
what kind of G, I guess Chetan, what kind of G protein are you looking at? I was happy Muslim kind of clarified his type of G protein that is receptors
Right.
to work on, and that is why this paper kind of in the very beginning, like upfront, it clarifies that mu opioid receptors, they are actually GI and GO type of receptors, and how can then GI or a GO receptor activate phospholipase C beta 3 when we know
GQ.
widely GQ kind of
Yeah,
does
this is
this.
cool. Yeah.
So let's see, like the title of the paper is genetic alteration of phospholipase C beta 3. That is why like possibly they looked at one of the isoforms
Isoforms.
of phospholipase C to understand if other G subtype G proteins if they can activate phospholipase C, and also if they can alter the response that we see when a mu opioid receptor is activated. Right?
Yeah. Cool.
Yeah. So before I go ahead, and talk about beta gamma, the role of beta gamma here, I'd like to talk about mu opioid receptors so that like we are on the same page. Mu opioid receptor, they are widely targeted for the analgesic effects. We know morphine binds to mu opioid receptors to provide antinociception. And since they are coupled to GI and GO type of proteins, we would expect these outcomes as an inhibition of the adenylyl cyclase, activation of inwardly rectifying potassium channels like potassium ions that have gone out, come back to the cell, and inhibition of the basically intracellular calcium channels. So these are calcium channels that are they're located inside the cell. We have calcium channel storage within the cell as well. So these are those channels. And then this paper, most of the work that this group did is based on these previous finding that mu opioid receptors they do activate phospholipase C, and they were like really interested to know how like what form, like if it is phospholipase C, then what isoform. So this is just for knowledge that phospholipase C catalyzes the reaction wherein phosphatidylinositol 4,5-bisphosphate is converted to IP3 and DHE. IP3 is inositol triphosphate, DHE is diacylglycerol, and both of them, they are like very important secondary messengers. IP3 increases the intracellular calcium by releasing calcium from intracellular storages.
From where? Do you know? You remember?
I heard like Melanie's presentation where I saw that.
Where is it coming from? Where is the intracellular calcium stored?
It's
Mainly.
So it is the presentation.
It's
Matt knows.
Particular.
Matt knows.
It was endoplasmic reticulum.
Yeah, it's stored in the endoplasmic reticulum.
Melanie has had a really nice pathway explained. when she
Yeah,
was
that's
doing
fine.
the
Yeah, I
process.
just testing.
And DAG activates protein kinase C, which kind of has its own downstream
Right.
downstream signaling, as it helps phosphorylate
You might need to talk louder for Chetan, sorry.
Oh, sorry.
Yeah.
Yes. And then, like we have four different isoforms of phospholipase C. I don't know why do they nomenclate it as like beta. If do they have like alpha
Yeah.
or something else as well? I don't know. I do not
Yeah,
find
that's
it,
I've always
but
seen
then-
with beta. Ah.
So yeah, so it's PLC beta 1, 2, 3, and 4. The the difference is beta 1 and beta 3 isoforms. They are mostly found in all types of cells, except like beta 3 is not found on non-hematopoietic cells like the lymphocytes or the bone marrow derived cells. Beta 2 is found on hematopoietic cells, and beta 4 on some specific neurons. No, the important point here is all these four isoforms, they are very well activated by the G alpha subunit of the GQ type receptor. But what this group found in vitro, and they haven't reported the results, that PLC beta 2 and PLC beta 3 isoforms, they are activated by the G beta gamma subunit. So this led them to hypothesize that, and before I read the hypothesis, I'd like to show what led them what led them make this hypothesis. So there is previous evidence that cytokine release is also controlled by even the cytokine receptors. They are G-coupled receptors, and the decision to stop a cytokine response is governed by G beta gamma, like G beta gamma mediated PLC activation.
Okay.
Phospholipase.
Negative feedback. So bringing back homeostasis.
Right.
Homeostasis.
Yeah.
Told you it'll never go away. I tell the PharmD students the very first thing I teach them in HPP is homeostasis. And I told them you'll hear it over and over. It never goes away, ever.
Yes.
Okay.
So the hypothesis that they state, and I state, like negative feedback regulation of mu opioid receptors is mediated by the beta isoform, and
Beta
this
3
is done by
specific.
activation by the G beta gamma subunit of the GI or the GO, which is something like new class of G proteins. And they also wanted to highlight that the beta 3 it constitutes a pathway that involved in the inhibition of opioid mediated responses. So basically, if I have to believe them, I think alpha subunit of the G protein was doing most of the anti-nociception or analgesic, was giving most of the analgesic effect. But because there's also like everyone inherently has G beta gamma subunit as well, morphine is not able to go beyond the suboptimal response to provide the maximum response at lower dose.
Yeah.
So on my next slide, I'll explain the animal model that they use. So part of the beta isoform of phospholipase C was kind of disrupted by the neomycin resistant gene, and it was then kind of electroporate, like you by electroporation technique you kind of deliver the faulty gene into the embryonic stem cell, and the embryonic stem cell is allowed to kind of propagate in vitro. The offsprings that were produced were kind of crossed with the CD1 mice, so it was adulty mice first, and then the CD1 mice. They kind of also have shown the background of mice did not affect the study. And the CD1 mice offsprings were bred till the time they kind of received homozygosity for PLC null, basically beta isoform was nullified totally.
That's cool. So electroporation basically just makes holes in the cell membrane so that the DNA can get in. Yep. The plasma. It's probably some kind of plasmid.
And they also use some gene targeting construct. They did not mention what, but I believe there's some vector, some viral vector. And then the first experiment was to test whether the PLC beta 3 isoform was activated by mu opioid receptor and not by some other receptor, basically the GQ, which they want to get activated. So they used aortic muscle. They could have used dorsal root ganglion instead, but there's a reason why they used aortic muscles for this study. It's because they also wanted to test the GQ. The dorsal root ganglion did not have, like, mostly it is responsible for the pain signals, and it did not have the GQ. It has the GI and GO, and
Right.
that is one reason they, instead of studying at PRG, they studied the effects in aortic muscle so that they could just prove their point that the phospholipids C beta 3 isoform is kind of activated because of the activation of mu opioid receptors. So here they did some. The endpoint was the measure was measuring the intracellular calcium. I don't know how they did it. I tried reading it. It was some electrochemical technique.
Yeah, no, usually there's kits, but
but I don't know
honestly,
how they measure it. But they kind of tried to see the calcium currents within the cell. And so this side, I'm showing you the PLC beta 3 isoform deficient mice. The other side, you have the wild type mice. And first looking at the panel A, and on the y-axis you have the calcium currents. When a deficient mice, so they do not have beta gamma isoform basically. They do not have the beta 3 isoform of PLC. And when dango, so your dango is nothing but the endogenous enkephalin that body produces in response to any pain reflexes. So when enkephalin was given, and here in aortic, and another important thing is enkephalin can act only through mu opioid receptor. So yeah. So when they gave enkephalin to wild type mice, they saw intracellular calcium currents, and in the deficient mice, they did not see any signal calcium. They also incubated the aortic muscles with GQ mix. So GQ mix is nothing but all the ligands, mixture of all the ligands that act on the GQ type of G protein coupled receptors, and irrespective of the wild type or the deficient mice, they saw signals in both. So they kind of proved that PLC beta 3 is regulated by the mu opioid receptors, and also specifically by the G beta gamma. So in experiment 2, they wanted to confirm the effect of PLC beta 3 activation on the opioid mediated, basically the opioid agonist mediated analgesia. And for this, they performed a behavioral test wherein they wanted to check the tail flick behavior of mouse when pre-treated with morphine, and the tails were placed in 55-degree warm centigrade.
Yeah, they
water.
like-
And they wanted to see
yeah, they flick their tail. Yeah, they don't like the warm water or something, or just kind of.
So for the control, they set the time to 15 minutes. Like if they don't flick the tail in say 15 minutes, like they're done. Like 15 minutes was the maximum that was given to control mice. But then morphine treated mice, they mostly, they almost sorry.
They don't.
morphine
They
treated-
do
they
not.
mostly
Yeah,
don't.
the opposite.
Sorry,
Yeah,
the
we got it.
It's
Yeah.
the opposite side. The morphine treated mice, if they do not flick the tail,
Yes.
it's considered like by 15 minutes, like you're considered done.
Mhm.
That's the maximum that they went. And over here, like I have two panels. The first panel explains. So the circles that are open, they are wild type mice, and the circles that are closed, they're the deficient, like beta 3 isoform deficient mice. And on the x-axis you see the percentage of analgesia or the anti-nociception, and on the y-axis you see dose of across different doses of morphine tested this. And what they saw, if you look at the ED50, you'll realize
the ED50, like if I have to just manually measure, it falls somewhere around 2, and this falls somewhere around 10 or around 10. So this is really black and white. It is like 5-fold decrease in the dose required to reach 50% response received with the mice that did not have the beta 3 isoforms. That
So they're
means
basically reducing the negative feedback.
correct.
Right. Okay. Right.
So in less dose of morphine, you're kind of able to mount a response that is kind of 5-fold.
Right. Yeah. Makes sense.
And that was seen with irrespective of the dosage, drug delivery, like be it
IP.
intraperitoneal or intracerebral, they found the same response. Now they wanted to check like if this response was specific for opioid receptors. So what they did, they gave morphine to every animal, deficient as well as the wild type. They gave morphine to each one of them. They then provided mu-opioid receptor antagonist, that is beta FNA, and then the other antagonists are basically antagonists for other opioid receptors, that's kappa.
Yeah.
So what they found, the animals that received the mu-opioid receptor antagonist, they saw like less percentage
The
anti.
clock is ready.
Yeah. It's very
significant
yeah.
for
It's
mu-opioid.
obvious. Yes.
And this made them assay that this particular effect is because of the mu opioid receptors, so not because of the kappa or the omega or delta receptors.
Yeah. Right.
And then finally, in the final experiment, they wanted to prove that usually when PLC gets activated, protein kinase C also gets activated. So they wanted to prove that this effect of beta gamma mediated suppression of morphine response is actually mediated by protein kinase C.
So it's a phosphorylation event then.
Right. So yes. So even I was kind of studying to understand like why a phosphorylation event would suppress an excitability of a cell. So pain is nothing but like your dorsal root ganglion neurons. They're getting excited. They're more excited.
Right.
So why is PKC kind of behaving differently? But then they explained it really well. They said protein kinase C can also phosphorylate your alpha subunit.
I was just
and
gonna
also
say,
your
or
other
the receptor.
The
Yeah.
receptors.
Ah, cool.
Causing them to kind of
Not
do
be
the
as
opposite and
effective.
not
Yeah.
be. Right. So for this particular experiment, what they did, they again measured the calcium current, but this time in the dorsal root ganglion, the receptors, the neurons that usually carry pain signals, and these receptors have high density of mu-opioid receptors, and they checked this in both the genotypes and also what they did to prove that PKC, this entire effect was mediated by PKC. They gave a true, or I would say an active agonist for PKC, analog, an active analog of PKC, and an inactive analog of PKC, which is for alpha PMA and PA. And then they also have an untreated. So if you see, when PKC was given to a deficient mice, there was reduction in the calcium current. This just shows that though the beta gamma subunit, though this animal lacks the beta 3 isoform of phospholipase C, the addition of PKC externally is kind of taking care of
the activation of PKC. So
Right.
PKC is downstream of the
Right.
phospholipase C. Yep.
So,
Right.
and that's why they're seeing a reduction in calcium current, and also possibly they should be seeing a reduction in the efficacy of morphine.
Yeah.
So in conclusion,
Nice.
these are like, it appears to PLC beta 3 isoform activation appears to be mu-opioid receptor response, and this appears to be due to PKC activation also.
So it's beta gamma activates phospholipase C,
Phospholipase
activates
PKC.
PKC.
Then PKC kind of phosphorylating receptor.
Phospholipase. Okay.
And so in summary, so just the same points.
Yep.
Just to refresh. PLC beta 3 is regulated by the receptor and it is primarily mediated by gamma pathway. PLC beta 3 has a significant negative